Good morning, everybody. My name is Shayn Hawthorne, and I'm here from AWS. I'm actually the general manager of the AWS Ground Station, which is a new service that we launched into general availability a week ago on Thursday. And we launched into what's called Preview at reInvent 2018 last November. Andy Jassy actually did the launch for us at that time. It's really a pleasure to have you guys. It's kind of hard to bring up the end of a 4-day conference in Las Vegas with a Friday morning discussion. So we really do appreciate you guys all being here. And I say we because I'm honored to actually be here. I'm the general manager of AWS Ground Station, and I've got one of our lighthouse customers that we've been working with, working backwards on how to build a good ground station to meet the needs of a satellite developer and a company that's actually going to deliver Earth observation data. And that person is our CEO from Capella Space, Payam Banazadeh. And raise your hand, Payam. It's really cool to have a customer here to talk with us because I've been involved for the last 15 months putting together AWS Ground Station and building a service and getting to work with a lot of great customers. But it's always been a talk where I get up and I tell everybody, well, this is what AWS Ground Station does. This is how it works. Now we finally get to start bringing out customers who are actually building their systems to work with AWS as an integral part to the way the whole system works. And that's what Payam's going to actually be talking to you about after I give you a small introduction into AWS Ground Station and try to talk about some of the great things you can do with it. So without further ado, we're focused with AWS Ground Station on enabling and breaking down doors and barriers to help space startups and venture capital get into space at a lower cost point in an easy and simple way of getting into space. So we were inspired, if you've ever watched some of the discussions about how Amazon started in the past, by the fact that people would discuss how Amazon started by building on top of the US Postal Service, the internet, FedEx, UPS, places like that. They didn't have to build all those distribution chains. They didn't have to do all that hard infrastructure work in order to put together our own company that was able to deliver things and grow into what Amazon has done today. We in AWS Ground Station wanted to take the same approach. If you look at how space is changing with the advent of cube satellites, little small cubes that are like servers measured in U's, 1 U of a cube satellite is 10 centimeter by 10 centimeter by 10 centimeter, and you use these blocks to put together to build your satellite system. And then if you look at the fact that launch, there's a number of great launch companies now that have come up that are working very hard to make the cost of getting satellites into space very low. And so what does that mean? You've got launch, you've got the ability to build a satellite. You can now get those things into space, but you still had to build your own ground station network, or you had to go lease somebody else's, or you had to maybe borrow time on an existing one, and that could be expensive. Ground station was designed to get rid of another barrier so that really 2 people in a garage in any country in the earth would be able to build their own satellite system, get it into space, and then operate it from AWS. So with AWS Ground Station, we're going after the government market segment, higher education, and businesses of all sorts. Businesses that build satellites, businesses that use satellite data, and businesses that don't even know yet that satellite data will actually support their value proposition and enable them to deliver something to the world that they need to build. So AWS Ground Station is doing that by making a ground station antennas an integrated part of the AWS fabric. So what that's going to do for you as a user, as a builder of satellites who needs to operate and downlink data, or as a user of satellites who just needs to downlink data, we're going to give you the ability to pay by the minute to use a ground station as a service that you access through the AWS console, the same way that you would access S3, that you would access EC2, and any other type of service that we offer. And then in addition to paying by the minute, you're now landing your data on an antenna that's in close proximity to an AWS data center. And I'll get into where some of our regions are around the world in a moment. But the key takeaway of that is that now, within milliseconds, you're able to move that data from a satellite through the antenna, through the digital signal processing equipment, and into the AWS cloud, so that within seconds of actually moving your data and downlinking it, you're able to start processing that data. You've got compute right there at the ground station antenna. You've got storage. You're connected to AWS's petabyte level network around the world. And one of the coolest things, you now have access to all AWS services and features because they're built from the start to work with AWS Ground Station. And you're built on top of AWS's security infrastructure. You're able to use IAM. You're able to do all of the other things that AWS provides to every other builder to build in space. So we're trying to get that out to you so that you've got a network, you've got pay-by-the-minute access, no long-term contracts. You can log on and use it with your same AWS account ID that you use to build something in EC2 today. And then you have all these services and features that you can apply to your data. And what that's going to deliver to you, and what I think then Payam is going to show you why that's so important, is the ability to do things fast and the ability to have no boundaries, no limits on what you do with your data, because now you can do it anytime, anywhere, when you couple a satellite system that can work anytime, anywhere, through clouds, through trees, whatever you talk about, and enable that system to have access to the cloud at all times. So the way that this works is it's going to enable you to easily control your satellites, downlink data from your satellites, and ingest data. So AWS Ground Station itself is a fully managed service that provides. Okay, hopefully that won't happen. But you know what? I'm actually quite loud, so if the antenna goes down, we're good anyway. But so you're able to do an AWS Ground Station as a fully managed service. You can access it through the console. We have procedures as you go in and navigate where you just click on the button to start what we call onboarding. Onboarding is to help validate that your space system will work with Ground Station as a service. Helps to make sure that we have correct ownership validated, and then we can whitelist you and associate your satellites with your account ID. And that's important. Work with us as we go through that, because we want you to have one account ID that you actually use with your satellites, and so you need to pick the account ID, because a lot of companies and organizations have multiple account IDs that they're using for different activities. So you'll want to pick one that you use with us. Then, on one hand of a spacecraft, if you're operating that satellite, it's just like you're running a data center. You need to do monitor and control. You need to take care of your system. You need to make adjustments to it. And so satellites are enabled by using S-band radio frequency waves to command their satellites or downlink satellite data health data directly into AWS. I'll show you some architectures in a moment, but what that means is that you can just use virtualized satellite radios, software-defined radios, to work with a virtualized command and control system, and you could do everything you needed to command and control your satellite and monitor its state of health through AWS Ground Station. But nobody puts a satellite into space just so that you can command it and control it. In the old days, you did, but not anymore. Now we're putting up satellites there to make money and to do good things for the world, and that means you need to receive data from the satellite. So satellites will be put up there to do collection of electro-optical data, in other words, imagery data that uses the same frequencies that our eyes work in. And then we have great satellites like Payam's going to tell you about that use radar energy to image the Earth's surface instead and build a highly precise set of data about the Earth's surface that can do many things, including making an image. And then you've also got people doing weather collection, hyperspectral, and there's a big group of people, some have been here at Remars this week, that are doing IoT collection. So they're building up a whole new suite of different IoT antennas and modems that can be integrated into things as small as an Alexa, and then allow you to actually communicate data up to a satellite if you're using that type of a device in an area that's not connected to a Wi-Fi or a terrestrial network. And then the coolest thing that's going to happen is once you've done this command and control, Once you've downlinked all this data, you're able to now process that data using our services, our features, and you're able to use our network to distribute that data to your customer. And this can be, any type of application. So I would encourage you guys to think big. Hopefully Remars was kind of an inspiring event for you to start thinking about that, because there is a lot of explored parts of the space domain that we're not applying that data correctly yet. I can see a collaboration in the future of imagery data with radio frequency collectors that are monitoring tags that come off of different containers, all the way down to drones, all the way down to the boxes that are dropped in your front yard as we start to deliver them to you. You can collect all that with spacecraft. You can fuse that together with other people's cell phone data and data that you've gotten from the Earth so that you could monitor when the customer's going to get close enough to pick it up. There's a lot of new things that we're going to be able to do if all of your space data is connected to the same internet that everything else is running on, and you're able to start to fuse this together. So that is the big payoff of the future. Now, to do that, you need to have a network around the world where you're able to collect and downlink data. Now, I want to highlight to you, you are looking at the same page that you would see at aws.com if you went and looked at our upcoming announced regions and our existing regions. So these are the regions around the world that AWS is providing our cloud services to the world through. And the key thing to take away from this is we're building AWS Ground Station in close proximity to a number of regions around the world. And so the takeaway to you from that is not to focus just on the fact that, as I would tell you, we're going to be building by the end of this year, we'll have 12 ground stations operational. We have 2 operational today, able to downlink data and uplink data to satellites, but we're growing out to 12. And as you look at this map, you'll notice within each of the orange circles, we have the number of availability zones that we have in each of those regions. We're building out our ground station antennas to become an integral part of the design of an availability zone, a data center, or a region. And the reason why that's important to space is that in this architecture, you're going to have instant resiliency and redundancy because it'll be functioning in the same way that an AWS region does, with our data replication going across different parts of the region. If one region or one antenna goes down, you'll have backups. Your data will be stored in other places. And those things don't even happen, but you should plan as if they would so that you've done everything you can to guarantee that your data can get to the ground. So you as customers will be able to take advantage of this architecture. So we're starting with 12, but as we continue to build new regions and new AZs around the world, we'll be putting more and more ground stations around the world as well. And it's going to grow into the hundreds of ground station antennas in the future as we continue to build AWS Ground Station. And you'll notice there's lots of good places on the Earth to put antennas. So what's one key thing to focus on? And that is that in the older days, spacecraft and satellites were producing data in the realms of megabytes per day. They've now grown to the point that we're talking about maybe gigabytes per day in the Earth observation market. Already at gigabytes per day, most satellite networks get taxed by that because they're working, I'm not exaggerating, in the megabits per second range for transferring the data around the world, or even if in a really robust area, gigabits per second, but not tens of gigabits per second. AWS Ground Station is from the start going to be 10 gigabits per second or more. And so to show you a real workload coming from a typical synthetic aperture radar type of program, 64 terabytes per day is a very typical amount of data to need to downlink. If you look at 150 megabits per second, you literally will get in a situation where you practically won't be able to get your data out of the ground station ever again. You'll just start pooling it there and storing it, and then you'll get into the issues of, hey, how do I find out what's important and what's not important and only move the things that I need while I store everything else, because it might become important in the future when a new algorithm comes out that can actually use the data. 350 megabits per second, 6 hours, 10 gigs per second, 13 minutes. So when you consider the fact that a pass typically will be a pass is how long it takes a satellite to go from horizon to horizon typically while your ground station is tracking it. A typical pass on a good elevation would be about 8 to 12 minutes for a pass. So you're literally getting to the point at 10 gigabits per second that we could move all of the data off of the satellite in the amount of time that it had a pass. That is critical. That gives the satellite developers the ability to plan on making products immediately after every pass, which means hopefully they've got lots of options to deliver things to their customers and monetize speed and monetize data and detail and not be limited by the network. So that's what we're trying to deliver to everybody, no matter what their mission is. And the way we're delivering it, this is the last meaty chart that I'm going to show you before Payam gets up and shows you the cool stuff, is that AWS Ground Station is built on the foundation of AWS. So our entire security and identity infrastructure, the resiliency and the redundancy of how we've built our regions are also supporting AWS Ground Station. And from the start, AWS Ground Station was built to be a regular functioning AWS service. So you can use AWS with AWS Ground Station with Chime. You can use it with SMS. You can use it in any other number of workflows that you've already built. You just need to connect to your VPC, an AWS Ground Station connection or stream through an Elastic Network interface. And if you have the account and you're able to then access that data, you can start integrating that data directly into your workflow. And the way we're doing this is on our side, we have our own antennas that we're integrating into our own ground stations. This is all AWS built and grown. And then we have our own onboarding services. We then allow you to then give us the satellite's location. In space speak, that's called your ephemeris. And the ephemeris of your satellite allows us to then predict where your satellite's going to be in an hour or 4 hours or 24 hours. And we get that updated every day from the surveillance networks that are tracking satellites around the world. And we use that then to help know where all of our customer satellites are. And we can plan ahead for the capacity that's needed in order to meet their downlink needs and to help them schedule. And then customers can come in and they use our API and they use a software development kit to build a machine-to-machine interface. If you want to make your systems just automatically task and schedule the ability to communicate with the satellite. Or let's say like you're in a high school or a university, at the top you can use an AWS console and you can just log on and you can load up your satellite, its configuration data, and you can use a graphical user's interface to schedule and set up 1 or 2 contacts per day. It'd be a great way to educate students on how to work with satellites. I would even tell you all, you could do this today. There's a number of cool satellites around the world. For example, one's called Terra, one's called Aqua, that NASA has put up there, and they downlink data to the Earth all the time. And they want people to use that data. It's a great science experiment for your kids. You could actually log on to AWS console and you could schedule a contact with Terra and downlink data from Terra. And then there's data on the web for even how to demodulate that data and turn that into something that you could look at as an image. Really cool thing that you could do. You can do it on AWS Ground Station today if you wanted to. And then we also have then orchestration to make it all work. And we have software-defined radios, modems, and digitizers that then allow us to move that data into your VPC, where you can either use our equipment or you can bring your own. You could build your own software-defined radio using GNU or a number of other different products. You can build your own what's called a front-end processor, which is after you've demodulated the data and put it through your radio, it becomes raw data in what's called baseband in the satellite world, and it needs to be converted into objects and files and things that you can actually use on an IP network to make pictures, make different products out of it. And then you could also use your own command and control, your own software modem. And we're encouraging a lot of our partners and folks who build things on AWS to put this into marketplace so that they can offer those products up to you and you don't even have to build any of that as well. So I would close by saying AWS Ground Station is changing the way space is going to work. We really wanted to make space easy button simple, low cost for our operators and our customers to use, and enable people to do new things with space that you've never thought of before. So that's going to impact how you build your architecture. You're not going to build it the way you did in the Sputnik days or in the old days of when Skylab was up there. You're going to be building it in today's days when people are saying we're going to be on the moon in 4 or 5 years, and we're surveilling the Earth to help solve problems. So I'd like to introduce you again to Payam, the CEO of Capella Space, who's going to tell you about a really cool new program that's coming, and it's going to enable you to see how those architecture designs can be impacted as you build your own system.
Thanks, Shane.
Thanks, Matt.
All right, good to be here. How many of you guys have heard of Capella Space? Show of hands if you could. Okay, that's pretty good. And how many of you are from the satellite industry? Okay, I might offend some of you. I apologize about that. So the way this presentation is set up is I'm going to talk about why I believe satellite imagery is really, really critical in 21st century in the coming decades. It's going to be critical for us to integrate satellite imagery in our workflow. Then I'm going to talk about the barriers that exist right now in using satellite imagery. And then at the very end, I'll talk about how the partnership between Capella and AWS is meant to really start removing some of those barriers and enabling you guys to use satellite imagery a lot easier. We are living in a completely, I'm one slide behind. We're living in a very different world. It's a very globalized world, which means our problems are also not localized anymore. If a tribe in Africa, in the Sahara deserts of Africa, had to really only had to worry about a neighboring river and the quality of the water in the neighboring river, didn't really have to care about the politics of America, didn't really need to know about the politics of America or the policies of Asia or conflicts of the Middle East, we know that that's not the case anymore. The problems of one part of the world impacts the problems of another part of the world. More specifically, I believe some of the challenges that we're having, that we're going to have in the 21st century, some of the big ones, nuclear challenge, the technological challenge, and one closer to my heart, ecological challenge. These are also very global problems that require global collaboration. It requires us to understand how one event in one side of the world is going to impact another event in another part of the world. And it requires us to understand the links between this very complex, intertwined society that we've built. And I say this, and you might be wondering why am I talking about this, because space by definition is also very global. It's one of the only ways that we can look at the entire world from a very neat perspective, from the global perspective. You know, a satellite is passing over Brazil, 20 minutes later it's passing over Europe, 20 minutes later it might be passing over Russia, 20 minutes later it might be passing over United States. And so you get to understand the links between some of the events that are happening and how one cause and another reaction might be related to each other. Specifically, just digging a little bit into the ecological challenge, we know that we're going to have some of these problems if we don't drastically change how we're treating the planet. And some of these we're already seeing, right? We know that the ice caps are melting. We know that we're going to have, the deserts are going to be expanding. We know that oceans are rising. And we know, and we've actually witnessed that we've seen more frequent extreme weather. I mean, these are things that are happening as we speak. And the consequences of these are, you know, agriculture production is going to be impacted. That's going to impact the food security. There will be places that it's just not livable anymore because it might be underwater. And there will be people moving and migrating from one place to another. And so I believe building a non-terrestrial infrastructure that allows us to monitor our planet, allows us to understand and maybe even predict some of these events, allows us to observe as these events are happening, is going to be absolutely critical in the 21st century as we're dealing with some of these problems. And even though, you know, the world is more connected, even though there's a lot of uncertainty, it's moving really fast, and the changes are a lot more rapid, in order for us to make better decisions again, we need to have access to a global scale, accurate and timely information. And I believe space is going to be an important part of that chain. Outside of the sort of these other sort of global scale problems, businesses are also realizing that satellite imagery is going to be critical in their workflow. I mean, if you own you know, a big operation right now, if you're an oil and gas company, if you're companies like SAP and IBM, you're hiring data scientists that know how to deal with satellite imagery because you're realizing the ability to look at your operations around the world is going to give you an edge among your competitors. You can have business intelligence, and you can monitor your assets around the world a lot easier. So this is something that over time, it's going to get more traction, and we have to think about how that's going to impact all the businesses. Don't want to be a party pooper, but the problem is there are a bunch of barriers in using satellite imagery. It's not easy. It's an old industry built mostly around government, and so it's not really easy right now to use satellite imagery. Some of the barriers I'm listing here, some are sort of out of our control, darkness and clouds. Most of the satellites that are out there, they can't see through clouds. They can't see at nighttime. The resolutions sometimes are not really at a scale where you can look at cars and you can see changes. Typically, we've been launching satellites in a very specific orbit that can only observe planet or any location in the world between 10 a.m. and 2 p.m. And so anything outside of 10 a.m. and 2 p.m., well, satellites are really not looking at it. That's a problem for government because you can predict where these satellites are and their passes, and you can just you can hide outside of that time frame. And for businesses don't stop after 2 p.m. or before 10 a.m. It's 24/7. So how do we fix that problem? The revisit is not that great. There are a bunch of satellites, but you can't really persistently monitor a place throughout the day and night and understand how things are changing. And the reactions are really slow. In order for you to get your images, as Shayn mentioned, it takes a long time. And it's a lot of unreliability. People are not actually willing to commit and sign up for a service and guarantee that you will receive your imagery at a very specific time. And so more specifically, getting into some of these problems, this is the dark and night problem. We don't really think about it that much, but it's day right now here. Somewhere else in the world, it's nighttime. And half of Earth is covered. Half of Earth is nighttime, and the other half is daytime. Well, guess what? The majority of the satellites that are operating right now, they're using optical imaging, and optical imaging works just like your phone. Doesn't really get pictures, doesn't grab good pictures in the dark. And so half of Earth is out. And also turns out half of Earth is cloudy on average. And by the way, this is very dynamic, so it's not a fixed 50%. The clouds might be here now, but they're moving somewhere else. And when you combine these two, 75% of Earth at any given time, it's either cloudy or nighttime or a combination of the two. And so really the observable Earth, with majority of the satellites that we've built and put up around our planet, is really 25%. And that 25% is actually also dynamic. It's changing, it's rotating, right? So it's extremely unreliable to use optical imagery and be able to guarantee that you're going to be able to do a collect, because there are things that are totally out of your control. You don't show up at a gas station with this sign, right? You don't show up at the gas station that says, sorry, we're closed because it was cloudy. You don't go to the airport and all the flights are canceled because it's a little too dark and the pilot can't fly. But that's exactly how it is in the satellite imaging industry right now. This always cracks me up. Some of our customers have to have a fax machine and order their imagery with a fax machine, right? Like you have to type up your order. I don't even know where you buy a fax machine these days, maybe Amazon. And you have to fax them, and then someone on the other hand has to be present at, just right in front of the fax machine, grab that piece of paper and go input it somewhere else, and you get your order, right? Sometimes you have to call them. And by the way, sometimes they're not open Saturdays and Sundays, right? So if you want to grab an image on a Saturday, sorry, come back on Monday. When you order your imagery, some of our customers told us that the images were so much, the data was so much, that they actually had an option for shipping us hard drives, like shipping like physical hard drives to you, right? And if they're very sophisticated, maybe they're doing FTP. So it's a very outdated infrastructure that really causes the reactivity to be very slow. So the way the satellite imagery typically works is you put an order, then they schedule that order, then they uplink that order to the satellite, they task the satellite, then it takes some time for the satellite to come over the area of interest, that's sort of the collection, and then after the imagery has been collected, then the data gets downlinked, then it gets processed, and then then you can access it maybe through a hard drive. If you take out the collection time, which is really out of the operator's hand, it's just how long does it take for the satellite to get there, and if you add up how long it takes right now to order, to schedule, to uplink, to then downlink, and then to process and to deliver, on average, we're talking about 12 to 24 hours. And a customer of ours who's spending millions of dollars told us that the best they've been able to get is about 8 hours. Right? So if you think about that, and by the way, these are not cheap images. These are like $2,000 to $8,000 per image. So if you think about that, it's probably faster for you to just jump on a plane, go over there and visually inspect whatever you wanted to look at. Maybe you can even do it in business class and save some money, right? So it is not fast. It is not easy. And if you think about how business time has evolved over the last many hundreds of years, it used to be years, right? Marco Polo, it took him 24 years and 1271. Used to be months. There was a road trip passage across the Atlantic was 3 months. That's 1750. Weeks, Pony Express was 1.5 weeks. That's 1860. New York to San Francisco, rail, that was 3 days, 1876. Concorde, New York to Paris, that's 1977. That's hours. 10-page fax in the late 80s, 7 minutes. And now we're doing business in seconds, right? You're sending emails and texts and tweets, and it shows up. And satellite imagery is right somewhere in the middle. It's in the 1960s, because it's taking somewhere between many hours and sometimes days for you to actually be able to receive your imagery and act on it. And so in the world where business is in seconds, how do we expect to use satellite imagery in our benefit? And I'll just use one very specific business example. Port of Nagoya, 1.3 million cars that are exported annually. That's roughly about 3,000 or so cars per day. If you're getting one image between 10 a.m. and 2 p.m., and it has to be perfect weather condition. By the way, ports are usually cloudy, so you can't even see that. And then it takes you another day to deliver that image to the customer who might be interested in how many cars are getting exported. You've lost millions and millions and millions of dollars of export and information by just that process, right? So it just doesn't really work for business. What we're trying to do with Amazon is to change that paradigm, right? So going from 12 to 24 hours average of reactivity to less than 30 minutes on average, and with real time actually being achievable in the midterm, in the mid to long term. And so this allows the customers to task our satellite. The satellite will be there and take an image, and then be able to actually react to the image, because they'll receive it by the time where maybe they were looking at a ship. Before the ship has gone, they've received the image. They know where the ship is. Maybe they can go after the ship. Whereas before, you're talking about the next day. The ship is gone, long gone. And the imagery might not be that important for you anymore. How are we doing this? Launching 36 satellites that are all weather, all night. Majority of satellites are using optical imaging. Our satellites use synthetic aperture radar. Synthetic aperture radar is an active imaging system. We're sending radar signals from our satellites. They're in X-band, so clouds are totally transparent. We go through the clouds, we penetrate the clouds, and because we're sending our own signals, it's as if we're carrying a flashlight. So we can see even without the sun being out. We launched our first satellite called Denali in December of 2018, 6 months ago. And we've been using Denali to build all the ground infrastructure and validating all the technologies that we've built. We're launching our first commercial launch called Sequoia in 6 months, end of this year. We have 6 satellites in production that's going to go up in mid-2020. And we're on the path to get to 36 satellites by 2020 and 2022. And that will get us 25-minute average global revisit. So I would be able to look at Port of Nagoya every 25 minutes of every day and every night, all weather and all night, all the time, on average. And so that's one piece of the puzzle. The other piece of the puzzle, which Amazon is really helping us with, is how do you make sure that the flow of data happens really, really fast, right? So you've got the satellites there, you've got the opportunity to collect very quickly, but how do you make sure the reactivity that we talked about doesn't really exist today is there for rapid delivery? So the user comes in, there's API. If the user has their own workflow, they can just integrate us within their own workflow. If they don't, there's a nice GUI. You can get on and you can task the satellite. The request comes through us. We schedule it. It instantly gets routed through a geosynchronous communication satellite to our satellites within a couple minutes at most. The satellite goes over area of interest, collects the imagery. On average, 25 minutes later, there's an AWS Ground Station. We dump the data on through the AWS Ground Station. It instantly gets to the cloud, AWS cloud, gets processed in the cloud, and there's an API for the customer to access that data immediately after it's been processed. And this whole process will take, on average, 30, 40 minutes from the traditional 12 to 24 hours. So I have a marketing video that I want you to watch about how all of this is going to work out. And then I think we're going to open it up for Q&A.
The ability to see virtually anywhere in the world in high resolution and to do so quickly and in rapid succession has never really existed before.
Now you can request satellite imagery from your phone, tablet, laptop, whatever device you have, and within an hour or less have images downloaded to anywhere in the world.
Satellite imaging that used to take days or weeks to process is now almost instantaneous. Capella Space achieves this with our constellation of 36 satellites that are fast and flexible with rapid revisit rates.
Capella's Synthetic Aperture Radar system, or SAR, provides extremely high-resolution imaging regardless of weather or time of day. You can see at night, you can see in storm conditions, it doesn't matter.
We provide fast, reliable, and accessible information for a wide variety of applications from disaster response and recovery, infrastructure, intelligence, agribusiness. Really anyone who needs to know what's happening on our planet needs this.
The process starts by placing a request through a simple interface and identifying areas of interest.
Once the user request is placed, it's then instantly routed to the Capella constellation via a communication satellite.
The Capella satellite's then positioned for the task. This could be as small as a millimeter scale change detection in infrastructure to as wide as an entire country.
We provide a variety of imaging modes, and the satellite can acquire images of different locations during a single pass.
With the Capella constellation, another satellite will be on task within an hour or less, ensuring fast, reliable, repeatable acquisition.
Once the images are acquired, the satellite then downlinks to a global network of ground stations, ensuring rapid delivery of high-quality imagery.
Capella Space has the fastest timeline from order to task to delivery. Our system is flexible, agile, and reliable. We gather accurate imagery with high revisit rates. We truly are using space to bring you closer to Earth.
Thanks, guys.